Hello and welcome to Multiparadigm Data Science with the Wolfram language. Section 3, Get to Know Your Data. In this section, we will look at functionality useful for the explore stage of the multiparadigm project workflow. Exploratory data analysis is really about trying to gain an intuitive understanding of the data. How are the samples spread out in feature space? How do the features relate to each other? Without any analysis, can we just look at the data and make some sense of it? We've talked about setting up questions right at the beginning of the multi-paradigm project workflow. However, the explore stage is where a lot of those questions can change and new questions emerge as we try to figure out what the data has to offer. Sometimes this stage is also used for data QA, checking the quality of the data and assessing whether it is useful and sufficient for the project. Tools used for exploratory data analysis or EDA can be categorized as graphical, providing pictures, or non-graphical, providing stats and numbers. Univariate, exploring one feature or variable at a time, or multivariate, exploring combined behavior of more than one variable, usually two. Humans are visual beings. Instead of staring at a column of numbers, human pattern recognition abilities are better used in visual explorations, checking for trends, shapes of distributions, gaps, outliers, and so on. To literally look at the data and examine each feature on its own or in comparison with other features, we can use scatter plots, bar charts and pie charts, histograms, box plots, cluster visualizations, time series plots, and so on. Let's try some visual explorations with Fisher's iris dataset. It has the length and width of petals and sepals of 3 species of the iris flower. Scatter plots are a simple and easy way to look at the correlation between two variables. Here is how the sepal lengths of the Setosa species measure against the sepal width. A scatterplot matrix shows the pairwise relationship between multiple variables. Here we see how the sepal length corresponds to each of the other features, sepal width, petal length, and petal width. We can repeat this for each variable in turn, thus creating the scatterplot matrix. Here is the matrix showing the relationship between the 4 variables of all the 3 species of iris. Now let's look at bar charts and pie charts, 2 other common tools for visual explorations. We'll use the Old Faithful eruptions dataset, which provides the eruption time and the waiting time to the next eruption for the Old Faithful geyser. Let's focus on the durations of the eruptions, elements in the first column. We can group the samples into 4 specific bins, less than 2 seconds, between 2 and 3 seconds, 3 and 4 seconds, and more than 4 seconds. We can identify in this list that the 4th number is larger than the others, but a bar chart or a pie chart really allows us to compare these numbers visually and immediately understand that the eruptions more than 4 seconds are the most common ones. Some other visualizations that can be helpful in exploring the data are box whisker plots, which show the max, median, min, as well as the first and the third quartiles. Violin plots are similar to box plots, but also show probability density of the data at different values. Finally, quantile plots compare the empirical quantiles of the data values against the quantiles of a normal distribution. Histograms are very useful for exploring quantitative variables. They provide an idea about the shape of the underlying distribution. For the duration of the eruptions, the histogram immediately shows 2 distinct groups. Paired histograms can help compare the distribution of values of both variables. For example, here are the 2 sets of random numbers from 2 normal distributions with different mean and standard deviations. And here is the paired histogram comparing them. Let's compare the duration and wait times from the Old Faithful data with a paired histogram. Only we have to scale the duration values to be in the same range as the waiting times. Overlaying plots is useful for comparing a fit with the original data, since humans are better at recognizing deviations from the straight lines. Here is a comparison of the histogram of the wait times to an estimated distribution for the Old Faithful data. Now, the trusty old scatter plot can highlight obvious correlation between feature variables, but it is also possible to explore correlations by visualizing multivariate data in 3D through density projections and histograms based on binning or kernel density estimation. Clustering data is often used to separate data into groups or to identify subgroups within a dataset. It only takes a little bit of Wolfram language code to quickly build an interface to interactively explore different clusters in the data, thereby offering the opportunity to identify interesting outliers. Let's look at some other ways of quickly visualizing clusters in the data. Clustering tree creates a weighted tree from a hierarchical clustering of data elements, while a dendrogram creates a tree where the heights of the nodes are proportional to intercluster distances. Before we end this segment, let's look at a special type of scatterplot where one of the variables is time. So we have some unit of time on the x-axis and plot on the y-axis the change in values of the dependent variable with respect to time. Here is the daily mean humidity of Champaign, Illinois in the last year, showing May was drier than other months. And here's a similar plot for the weekly mean temperatures where the winter dips and summer peaks are easily identifiable. These visualizations in time allow us to quickly spot any trend in data. In summary, we looked at various tools for visually exploring our data. We looked at scatter plots, bar charts and pie charts, histograms, box plots, violin plots, cluster visualizations, and time series plots. We hope you will be able to use one or more of these visualization tools in the explore stage of your workflow in your next data science project.